All right. So here's an example of a SQL feature that Squeal doesn't yet cover, which is the any and all constructions that check arrays. So there is any and all in Squeal, but they only check against subqueries, not against arrays. So what is the difference between those? How are they related? So here's the documentation for any sum array. And it says that if we have an expression and an operator, we can compare that against any, and then in parentheses, some array expression, which gets evaluated. And then the right-hand side must yield an array value. The left-hand side is evaluated and compared to each element in the array using the given operator, which must yield the Boolean result. The result of any is true if any true results is obtained, false otherwise. And we also have all, which has the exact same idea, but instead of checking against any of them, it checks against all of them. So this is not unlike Haskell's any and all. So how do we implement that? Well, it's very similar, I suppose, to in the previous set of documentations, we have subquery expressions, and there we have any, and the only difference is instead of an array expression here, we have a subquery. So we can look at that as a model. So here I am in array. I'm going to make a function array any and array all. And let's start the REPL. Okay, so what is it complaining about? Maybe just that it hasn't, not in scope, R any. Did I call it the wrong thing? I called it the wrong. Okay. So over here in subquery, I have sub all and sub any, which should be much the same as R all and R any. Let's do it in the same order that we have it over there so we don't get confused. So if we copy the type signature for all and any, which happens to have the same type signature, this almost looks right, except that here in the third argument, we have a subquery, when really what we want is an array expression. So what is the type of an array expression in Squeal? Well, it's sort of like this. This is an expression of type Taiwan, but what do we want the expression its type to be? We know that we want it to be a, let's say, a not null PG var array of something, right? And what do we want this something to be? Well, here we're giving an operator argument that checks, that compares Taiwan and Tai2, giving us back a logical condition, a Boolean expression. So this one we want to be the right-hand side of this operator. So this is going to be an array of Tai2. And we can say that this is an array. Okay. So let's see if that compiles. It doesn't, because it doesn't know about conditions. So we need to import logic. Okay. Cannot instantiate unification variable A1. Where does it see an A1? Hmm. Have you guys seen this kind of type error before?
No.
No, me neither. Let's see if we if we use
Sounds like rank n types to me.
rank n types. So what rank n types do we have? We have operator as a rank n type. So maybe what we need to say is this. Okay. Thank you, GHC. Okay. So let's go ahead and instantiate these variables. So we'll call the expression x. The operator, I'll use question mark for my sort of generic operator. And then I'll use x's for my array. Okay.
By the way, the reason you had an error earlier, even though you wrote equals undefined, is because undefined cannot be instantiated to any type, just to most types. But if you had written r all equal r all instead of equals undefined, it would still be bottom, it would loop at runtime,
Yeah.
but it would type check.
Okay, I like that. Let's try it over here. Okay, so it's just warning us that we haven't used these variables, which we haven't, so that's fine. And then we want to look over here. Okay, so it looks like we just take the expression, we print the expression, print the operator, write any, and then inside of parentheses, print the array expression. Okay, so what does that mean? A condition is a kind of expression. Let's go ahead and take a look in logic. What is a condition? It's just an expression where its type is a null PG bool. So in order to build an expression here, well, we can actually just, since the operator here, sorry, this operator, right? What is an operator? That's actually another question. Okay, what is an operator? So an operator is a rank n type. Says, okay, I have a left-hand side and a right-hand side and an output type. And this says we're going to quantify over all these sort of namespaces and say this works no matter what namespace you're in, which basically means that you can't refer to any of those names inside of the operator. And given a left-hand side and a right-hand side, it's just a function that takes a left and a right and gives you an output. So that's what an operator is. And the quantification makes sure that, you can't populate this with anything other than things that work across any database. So we can use this operator. We can say, okay, what goes here and what goes here. All right, so for the first one, it wants an expression group lat with db params from Taiwan, which is exactly what this is. So we can put x here. And for the last one, it wants this kind of expression of type Tai2, because that's what this operator is asking for the right-hand side. But we don't have one of those. We have an array. So we'll just kind of do a little hack here where we say unsafe expression and then we'll render x's like that. And that's the same thing we were doing over here for subqueries, where we said unsafe expression, and then we rendered the query. And then here we get a little hint, oh, I forgot to put this syntax stuff around it. So the unsafe expression is, you need to say all, and you need to parenthesize this. Okay. Okay, and we can do the same thing for this one. So we'll put any. Okay, so these are our two functions. And let's see what it looks like if I do R all, and what's an example? We can kind of look over here for an example. What should it look like if I did, say, R all true equals, and now I need to construct an array, which I can do with array. And I can say true, false, null. Okay, and then we want to see what this renders as, or actually we want to go ahead and print it to the screen. Okay, so that looks good. That looks like what we would expect. So true equals all, array true, false, null. Are all true equals array true, false, null. So it's pretty similar to how the SQL looks. And it doesn't have to be a comparison operator like equality. It could be the like operator. We can be doing text. Hi is like. Oop, what's wrong with this? I need overloaded strings. Okay. So the nice thing now is to go back over here and add some doc tests. So if I do this, then I expect to see this. And if I do this, I expect to see this. Okay. And while we're at it, we'll put some, let's move these docs from here. Well, these are the docs for all. These are the docs for all. Okay. Make it into a little poem. All right, so now let's take a look at what the docs look like. Okay, so now if I look in array, I have my array all with documents and examples, and we can check that the examples work. We'll do stack test, we'll PostgreSQL, and we'll check that the doc tests passed. I don't understand why Haddix, stack test, stack build, and stack REPL all cache their own individual versions of the compilation, and as soon as I run one, it forgets the other ones, so it can't quickly do this. Oh. So these exceptions we're getting from the doc test is because I haven't started Postgres. So these are okay errors for now. So we only had the 3 errors that came with actually trying to run Postgres, which we can probably I always forget the thing I need to write.
I think brew services start Postgres should do the trick.
I usually do this one. I can try that. Brew service.
I used to do that too, but it just doesn't seem to be needed.
Oops. Nope. I wonder why it's still having trouble with that. Well, I'll worry about that later and not force you guys to watch me flounder on the command line. So we'll go ahead and make a new branch. And we'll say, oh, we're missing something, right? We need to do the same examples here. Okay. So let's just see that it compiles. And we'll say resolves. Okay. PR. And just one last look at the docs. So while we're waiting for the docs to build, there's a couple others that are relatively simple. There's, okay, we want to add locking clauses. So what's a locking clause? It's this for clause. So when you say for lock strength, maybe you specify a table or not. You say no wait or skip locked, and this has to do with concurrency. So it gives you some fine-grained locking control on concurrency. And this is like inside of a table expression, but this one might be a little bit complex because it's sort of in the weeds. Another example of an open piece is from clauses in updates. So Mark pointed out this one. Update. In an update, you can have a from, which lets you reference a table, not the one that you're updating, but another table. And right now, Squeal doesn't let you do that, but it shouldn't be too hard because it's very much like in deletes. In deletes, there's a using clause, which lets you do basically the same thing, where you render a using clause. A using clause is either there is a using clause, in which case it's a from clause, so from, just like we saw, or there is no using clause. And we could probably do the same thing, maybe named slightly differently or not, for updates that we're doing here for deletes. So that's two pieces of syntax that we'd like to add. Now that we've added any and all, and this finished compiling, so we can take a look. And that's our examples of any. Okay, so that's extending Squeal, at least in one small way. Why don't we take a look at the examples that Sam was trying to do in Squeal, and we can struggle together.
All right, let me share my screen. Should we stop the recording?
Oh, yeah,
Is it still helpful for others to see me struggle?
It's up to you. You don't want me to record anymore?
Well, I think it will be a lot less useful than the things you've already recorded. Yeah.
Okay. Okay, so stopping the recording.